All right, now let's look at the multiplicity and how the polynomial, how the graph of the polynomial is going to look at each of the zeros. Okay. So we're looking at zeros and multiplicity. All right, so the zeros of a function are the same as the x-intercepts of the graph if the zeros are real numbers. Okay. All right, so when you're looking at a problem like 26, if you were looking for the x-intercept or the zeros for that function, you basically are trying to set this right here equal to 0. Okay, so that means either this factor would have to be 0, x plus 8 would have to be 0, or x squared minus 1 would have to be 0. All right, and then you can get the answers to each of those. So for this first one, for negative x squared to equal 0, x would have to be 0. You could go through the process of dividing by negative 1 and then taking the square root, but you'd eventually get x equals 0. All right, this one you would just subtract 8. Okay, and then for the last one, you could either use the square root method and think about x squared would have to equal 1. So x could be plus or minus the square root of 1, which would be plus or minus 1. Or that one could have been factored into x minus 1, x plus 1. And you could have then set each of those equal to 0 to get the positive and the negative 1. All right, now, so there are 4 x-intercepts, 4 zeros, 4 x-intercepts for this. Notice the leading term would have been a negative x squared times an x squared. Would have been a negative x to the 1, 2, 3, 4, 5th power, but the reason I don't have 5 is because this factor had a squared on it and only 0 would make that one work. I'll sometimes look at how many x-intercepts I should have had in order to make sure I'm on the right track, okay? But you don't really need that in terms of multiplicity. You need to be able to get the zeros, and then after you get the zeros, then you're going to think about what has to happen at those. And so we're basically on these asked whether it's going to pass through the x-axis there or whether it's going to touch and turn or bounce. So think about each of these. Think of the 0, the negative 8, the 1, and the negative 1. Think about the multiplicity of each of those. So the factored form actually helps you a little bit, I think, on this one to see it. The multiplicity has to do with what the exponent is on the related factor. So the multiplicity, these are the zeros here. The multiplicity would be the exponent on those factors. So that one had a 2. The negative 8 was corresponded to a factor that had an exponent of 1, and so did these two. So that means at 0, it's going to touch and turn. Okay, so that means this is out. At all the others, it's going to just pass through because the exponent on the associated factor is a 1, so it should behave like a line. Okay, so like a parabola here. And then all of these should behave like a line. Okay, so it should touch and turn at 0 and then just cross the x-axis at each of the others. So that would be D. All right, now the trickiest thing about this one is the fact that that was not completely factored, that this x squared minus 1 doesn't mean that you have a multiplicity of 2. Okay, that would have equaled negative x squared, x plus 8, and then if they had factored that, it would have been x minus 1, x plus 1. So it's really that negative 8, 1, and negative 1 all have a multiplicity of 1. All right, let's try these two. The next two are kind of tough because the original function is not in factored form, and that can be a struggle. So I wanted to do several examples of that. So this is for number 27. So we had f of x equaled x to the third plus x squared minus 42x. If it's not factored to start with and you're trying to figure out multiplicity, then you have to factor. So one thing I notice is there's an x common to all of those. And that would mean I could rewrite this as x times x squared plus x minus 42. And then x squared plus x minus 42 factors. 42 I could break down into 6 and 7. And then that would enable me to get the middle term of 1x if I make the 7 positive and the 6 have a negative in front of it. So now I'm looking at how each factor has an exponent of 1. And then I'm going to get what the 0 would be for each of these. So this would be 0. This would be negative 7. This would be positive 6, right? You would set each of those equal to 0. So those would be the zeros. And then the multiplicity of each one is 1. So it's going to behave like a line. So it's just going to cross the x-axis like a line. Okay, so what I'm looking for is a 0, a negative 7, and a positive 6. Okay. All right, so this guy's out, and this guy's out. And then I'm looking at all of them having a multiplicity of 1, which it says on both of those. But a multiplicity of 1 would mean it just crosses the x-axis. So your answer should be D. Okay. All right, let's try another one. This is another one that is not factored to start with. Okay, this one has the 4 terms, so this would be the factoring by grouping. I did include that factoring practice assignment at the start, knowing that we were going to have a lot of different types of times when we have to factor. So you may want to go back to that and practice a few of those factoring by grouping problems. What you do with those is after you get it in descending order, okay, if it's not already, you would put them in descending order. You just pair 2 of them up and you factor out the common factor. So I could take an x squared out of those first 2. Then I'd have an x plus 9 left. Then you consider the last 2, and here I could pull out either a 1 or a negative 1. I'm going to pull out a negative 1 because I need what's left to be x plus 9 so that it matches what I had here. So that's why I chose to pull out a negative 1. Now that x plus 9 is a common factor I can pull out in front. What's left would be x squared minus 1. And then x squared minus 1 can be factored into x minus 1, x plus 1. Now once it's in factored form, it's easy to get the zeros. So the zeros are what would make each of those factors equal to 0. So from here we know we'd get a negative 9. Here we'd get a positive 1. Here we'd get a negative 1. And notice the exponent on each of those factors is just 1. So the multiplicity is 1 on each, which means it's going to have to just cross the x-axis just like a line. So I need to be sure I have a negative 9 and then a 1 and a negative 1, negative 9 and then a 1 and a negative 1, and that all of them are just crossing the x-axis. Okay, so it would be this guy here. Okay.